You know, I'm rarely this harsh about AI model outputs, but this time I just have to say it. This is probably the worst model I've ever tested. So Meta and NVIDIA both dropped new models this week, one day apart from each other, and suspiciously enough, both of them are 30 billion parameters large, both of them are designed to run comfortably on consumer hardware, but there are stark differences in the way they operate. I tested both of them on a different set of tasks, and honestly, one of them is complete trash. The other one is actually quite usable. Which one is which? Well, you'll just have to stay tuned to find that out. So in this video, we'll take a look at both of these models, see how they work, and put them in a challenge match against each other to see which one is ultimately the better model. It's gonna be a lot of fun, so let's dive into it. So first, let's look at both of the models. First up, we have Muse Glimmer, which was published on Monday, which is a distilled version of their flagship model, Muse Spark. And it's built specifically so it can run on consumer GPUs like the RTX 5090, and they even have quantized versions that can run on just a regular M4 or M5 Mac. Now, rumor has it that the reason why they released this model was because they realized that Muse Spark is not that popular because everyone is still using either Claude or Codex, so they decided to go the open source route instead. I'm not sure if that rumor is true, but if it is, I wouldn't be surprised. But anyway, Muse Glimmer also ships with D-Flash support, which basically enables the model to do speculative decoding, which essentially works by having a smaller drafter model that guesses a whole chunk of 16 words at once, and then the main model just checks that guess and fixes whatever it got wrong. This gives you a 3 times bigger speed boost without sacrificing any of the quality. So that's a nice add-on, but does it actually work? Well, we'll see that in the tests. Now let's talk about what NVIDIA put out on Tuesday. This is Nemo Tron Lightning 3.5, and it's also a 30 billion parameter model, but it's built completely differently. It's what's called a mixture of experts model, and what that actually means is that instead of running the whole model every single time you ask it something, it's got a router that picks a handful of smaller expert subnetworks to handle each word as it goes. So even though the model is 13 billion parameters, on paper, only about 3 billion of those are actually doing work at any given moment. And that's the whole trick behind why it's so fast and cheap to run despite being this big model on paper. Now, NVIDIA also really wants you running this thing inside their own routing setup, which is called Nemo Switchyard. It's basically a system that automatically hands off each step of the task to whichever model is best suited for it. So it might bounce between open models, proprietary ones, even NVIDIA's own models, depending on what the task needs. So realistically, the best case scenario for Lightning is probably running it inside of this setup. But for this video, I'm going to run it standalone so we can compare it fairly against Muse Glimmer. So how do they both stack up on paper against each other? So they're both 30 billion parameters. They both support tool calling, which is great news because it means we can actually run some fun experiments with them. But Tron Lightning has a bit of a disadvantage. It can't see images at all. You can't hand it a picture and ask it what's going on. Muse Glimmer, on the other hand, has actual vision system built in, so it can look at an image and reason about it. There's also a real gap in context window size. Muse Glimmer can hold about 128,000 tokens at once, but Tron Lightning can hold a full million. So on paper, Lightning should be the model you reach for when you've got like a massive document you need to dig through, while Glimmer is more built for shorter, denser back and forths. Alright, now let's do some proper testing on both of these models. So I have a small Homelab workstation here with an RTX 5090 and 64GB of DDR5 RAM. And I've loaded up both of these models on an Ollama server, and I'm going to be querying this server through OpenCode, and basically this is what my OpenCode JSON setup looks like. So we got two models right here, and I've also got two MCP servers loaded. and one of them is an Adobe Premiere plugin built to control the editing software externally, and another one is an MCP server for Epidemic Sound to fetch some music. And this will come in handy in one of the tests that we're going to be doing later. Okay, but first, we're gonna start with a different test. I'm gonna ask both of the models to build a simple web page showing how an ESP32C3 microcontroller connects to a breadboard with a switch and a diode on it. I've got a pretty long prompt for this one, so I'll drop it in the GitHub gist if you want to follow along. Before doing these tests, I gave this prompt to Opus 5 to see what a state-of-the-art frontier model would give us, and I'm pretty satisfied with the result. Basically, it's just a visual guide how this electronic setup works with some kind of interactivity to see how the current flows and everything. Now, I'm not expecting that any of the models will do as good of a job, but I expect them to at least try to set up a simplified version of this. So first, let's run this test with Nemo Tron Lightning. And as we can see, the model immediately fired a bunch of curl requests to fetch some pages, and it was working through the task for about 5 minutes, and by the end of it, we got this, a blank page with some buttons. There are no visual elements, the buttons don't work, so at this point it seems like Lightning did not do this task properly. But I wanted to give it the benefit of the doubt, so I prompted it again saying that there are some issues on the page to see if the second round would fix it. And the second round took Lightning 6 minutes to finish, and by the end of it, we got exactly the same broken result. Nothing is displayed, the buttons are not working, so at this point, unfortunately, I have to declare that Lightning just completely failed this task. Alright, let's switch to Muse Glimmer and see how it did with the same task with the same prompt. So Muse Glimmer fired up a bunch of web fetch tool calls to fetch some of the pages, and the entire round was completed in roughly 2 minutes and 50 seconds. And by the end of it, we got this web page, which honestly was a lot better than what Lightning did. At least the page had buttons that were functional, there was some kind of representation of the current, and it did actually make a pin layout of the controller, and there are even some tooltips that explain what each area is and what it does. But unfortunately, it still did not create a proper wiring diagram. So I wouldn't say I'm satisfied with this result, but this is a big step up from what Lightning did with the same task. So I'm gonna give it to Muse Glimmer in this case. At least it tried, and honestly, I reckon with a few additional rounds of bug fixes, we could get it to a working version. But now, let's move on to the second test. And I'm pretty excited about this one because specifically for this test, I created an Adobe Premiere plugin that connects to the editor via the UXP Adobe Bridge. So this means that any AI model that supports tool calls can theoretically navigate Premiere autonomously and do certain actions on the editor. I tested it out with Opus 5 and it works very well. And if you want to check out this plugin, I also added a link to the GitHub repo in the description below. Alright, so since both of these models support tool calling, they should have no problems working inside of Premiere. And since Nemo Tron Lightning is custom tailored for more quick turnaround tasks like something that requires several rapid tool calls, I expect Lightning to be able to execute this task better than Muse Glimmer. But let's see if that is actually the case. So for the task itself, I have Premiere opened in a project here, and I have a recent Google Keynote presentation recording, and it is already transcribed. And just for the fun of it, I want the model to parse through the transcript and find all the occurrences where someone says the word AI, and I want it to create a fast montage of short clips of people just saying AI all the time, and then use Epidemic Sound's MCP server to add appropriate background music to it. So a pretty straightforward, simple task for an AI model. So let's see how Lightning performs. So it starts out pretty strongly. We can see that Lightning recognizes the tool calls and fires them very rapidly, and it was able to fetch the transcript and also find all the occurrences of people saying AI. And afterwards, it also successfully managed to cut the individual pieces and lay them out in a separate sequence. So that is all great, but then when it comes to adding the background music with Epidemic Sound, this is where things started to get a bit tricky. It found the soundtrack and it laid it on the sequence, but on the first audio track, which basically layered it on top of the speaker audio, which basically means that now there's no actual audio and we're just left with the background music. So I called this out in a follow-up prompt to see if it would fix the mistake, and indeed it recognized the mistake and moved the background music to a separate separate audio track and then declared the task done, when in fact we still don't have the speaker audio because it was deleted earlier. So then I prompted it to bring back the speaker audio, and at this point it went completely off the rails because while trying to salvage the audio, it started deleting the original tracks and it completely messed up the timeline. So at this point I was just too frustrated to continue. So I have to declare again that Lightning unfortunately failed at another task, which is a real bummer because I thought this is the sort of task Lightning would be best suited for. But anyway, let's now switch to Muse Glimmer and see how it performed on the same task. So once again, we started with the same prompt, and I noticed that Muse Glimmer was a bit slower in tool calling, but it did everything properly. It laid out the sequence correctly and found the background music and applied it to the separate audio track, and it even trimmed the duration of it to match the video track and also added a fade out effect to the music as was required in the prompt. So this already shows that Muse Glimmer is much more intelligent when it comes to identifying these sorts of details and small issues. So I was pretty happy with the first pass, and I can already confidently declare that Muse Glimmer is the winner of this task. But there's one more thing I wanted to ask it to do. I wanted it to change the background music because I wasn't quite satisfied with the first choice. So then I prompted it again to find another background track from Epidemic Sound, and it did so elegantly and successfully replaced the old music track with the new one. So well done, Muse Glimmer. You know, I'm actually considering using this one on a daily basis if I ever max out on my Claude token usage. So at this point, even with a task that is kind of custom tailored to the sorts of tasks that Lightning should be superior on, it still failed. So I want to do this final task where Lightning should be able to perform better just because it has a 1 million token context window. So for this third task, I wanted to actually put that context window gap to real use. So I grabbed something real off of SCC's website, and it is NVIDIA's own FY 2026 10K filing. It's a big document with over 100 pages of dense financial and legal limbo. And there's a little bit of a fun angle here too, because we're essentially asking NVIDIA's own model to go read NVIDIA's own paperwork about themselves. So the question was pretty simple. I asked the model to find what percentage of revenue came from NVIDIA's two largest customers, which business segment that revenue was attributed to, and then cross-check whether that same number shows up again later in the notes to the financial statements. So first, let's see how Lightning did on this task. Honestly, I expected this to be an easy one, especially for Lightning, because it is tailored to read through a large chunk of documents with its big context window. But look what happened. Its fetch request to the SEC came back with an error, and instead of just retrying, it fell back to the general search and ran with whatever came up, which turned out to be wrong. And it told me two customers made up 23% of revenue combined, split roughly 13 and 10% attributed to the data center segment. None of that is correct because the actual filing says 22 and 14%, 36 combined. So not only did it fail at this task, but it also failed to properly utilize its built-in tool calls because it couldn't even fetch a web page properly. But worst of all, it hallucinated the numbers that simply were not true. You know, I'm rarely this harsh about AI model outputs, but this time I just have to say it. This is probably the worst model I've ever tested. I mean, I even made it simple for Nemo Tron's Lightning. I tried to find a task that would be custom tailored to it, and it still failed miserably. God. But anyway, we still have to check how Muse Glimmer did with the same task. So when prompted Muse Glimmer with the same task, it took about 3 minutes to finish it, and it made a bunch of web requests. Some of them failed, but nonetheless, it still managed to work its way around it and retrieve the correct information, which in this case is 22 and 14% and 36 combined. So once again, well done Muse Glimmer, another test passed. So overall, where do we stand with this? Well, I would give Muse Glimmer a 2 out of 3 score because it did accomplish 2 of the tasks with an acceptable result. But when it comes to Nemo Tron's Lightning, dude, I am really disappointed. I wouldn't have expected something like this from NVIDIA, honestly. I mean, do they even test their own model? Can we actually trust their benchmarks? Is anything real anymore? These are good existential questions that we will not answer in this video, but subscribe to our channel and maybe we'll do something about it. So anyway, folks, those are the two models in a nutshell. So what I can take away from these tests is that I was pleasantly surprised by Muse Glimmer, and I would actually consider using this model on a day-to-day basis for certain types of tasks. But when it comes to Nemo Tron's Lightning, I've said what I've said, and I don't want to comment on it anymore. But those are just my thoughts and observations. What do you folks think? Let us know in the comment section down below. This time, instead of doing the regular outro, I'm gonna leave you with something funny at the end of this video. So let me present to you with the AI montage that Muse Glimmer performed on one of the tasks. Enjoy, and I will see you in the next videos.
AI assist.
AI, AI more AI, AI more AI power, AI to AI. AI is
AI the AI assist.
AI get AI to AI or AI to AI. AI to AI. AI to AI agent.
AI
AI over AI search. AI mode, AI feed to AI search. AI search, AI power, AI tool, AI over AI mode, AI search, AI mode, AI search, AI agent.
AI over AI mode. AI search.
AI agent, AI search.
AI play AI
AI can AI cloud.
AI tool AI sim
AI mode.
AI